Assalamualaikum and hello everyone. In this video, our group will discuss about green building material. In this modern era, the construction industry is evolving towards smarter and more sustainable practice, aligning with Industry 4.0 and Sustainable Development Goal SDG 9. However, conventional concrete and steel production contribute significantly to global carbon emission. As engineer, our group has selected a green building material to address this issue, mass timber, specifically cross-laminated timber, as known as CLT. This material directly supports SDG 9 by promoting sustainable industrialization and foresting innovation in infrastructure. Furthermore, it integrates seamlessly with Industry 4.0 through advanced automated digital fabrication method, where entire building components are manufactured off-site with high precision before being delivered to the construction site.
Let us examine its key engineering characteristics. As outlined in International Timber Engineering Standard, CLT is produced by bonding layer of solid wood in a crosswise arrangement. This alternating grain orientation yield is an exceptionally high strength to weight ratio, enabling it to rival the structural performance of concrete despite being significantly lighter. Regarding fire resistance, mass timber doesn't burn through to total failure. Instead, its outer layer char at a predictable rate, thereby protecting the structural core within. In modern practice, its use spans a wide range of applications, from load-bearing floors and walls to complex structural framework for mid and high-rise buildings. By substituting steel and concrete with CLT, we can drastically reduce the embodied carbon content of modern structure.
The innovation of CLT lies on a design and manufacturing workflow that relies entirely on BIM, Building Information Modeling. Structural engineer design the entire building digitally with millimeter level precision. This digital dataset is then fed directly to automate robotic CNC machine in the factory to cut out window and door components as well as complex mechanical connection. This seamless transition from digital code to prefabricated physical components eliminates human error on the construction site, minimize structural material waste to near zero level, and significantly optimize construction efficiency. Consequently, it can be said that cross-laminate timber (CLT) aligns engineering principle and Industrial Revolution 4.0.
Now, let us examine the key environmental sustainability benefit of CLT. Unlike concrete and steel, which release significant amount of carbon during manufacturing, woods act as a natural carbon sink. Through the process of carbon sequestration, trees absorb carbon dioxide as they grow, and this carbon remains trapped within the building's physical structure throughout its service life. Furthermore, in terms of energy performance, CLT possesses excellent natural thermal mass and low thermal conductivity. These natural insulating properties reduce heat transfer through the building envelope, thereby drastically lowering the long-term operational energy required to regulate the indoor climate.
Finally, the use of cross-laminated timber CLT in the construction industry offers the advantage of reducing installation time by up to 25%. This is because lightweight components arrive in the pre-packaged unit ready for assembly, much like a Lego set, thereby significantly lowering heavy machinery costs and on-site labor requirement. However, evaluating its implementation in a country like Malaysia reveals unique regulatory challenges. Traditionally, the uniform non-conform building by law UBBL and local JKR standards have imposed strict height limit on timber structures due to conventional assumptions regarding fire risk. To overcome these constraints, the Malaysian engineering community must continuously update structural design code such as MS 544 to recognize modern engineering principles regarding sharing the formation of protective char layer during a fire. In conclusion, cross-laminated timber is material that meets the criteria for SDG 9 and Industry 4.0.